Okay, everybody, welcome back to part two of the video lecture on Assignment 10, the in-class lecture um, for how to do SPSS and this assignment. So last part, I talked about coding these variables and getting the labels in for each different condition in the isolation variable, which is our main independent variable. So let me show you how to do the actual statistics in SPSS. So because we have one independent variable with three different levels, right? So a level of isolation, groups of 2 and groups of 4, and we have one dependent variable, what we're going to want to do is a one-way ANOVA, right? That's how you compare one independent variable through three or more groups, okay? So the other thing to keep in mind here is that things can go a little weird in SPSS from time to time, so we'll take it slow, okay? So the first thing we want to do is come into Analyze. This is how you're going to get through all your analysis in SPSS for the most part. And what we actually want to do is compare the means of the dependent variable, utilitarian decisions, between these three groups. So you go to Compare Means, and then come over here and click on One-Way ANOVA. All right? And so I already have it in here because I've already done this, but what it'll look like on your screen is you'll see these variables over here. You want to drag utilitarian decisions over to the dependent variable, and then SPSS calls factor independent variable. So your independent variable is going to go into the factor slot, and that's how SPSS refers to independent variables. So you click it over, and then we're going to go through these menus. In contrast, don't worry about anything here. I don't care about that. It's not important here. Post hoc is, however, you're going to want to click Tukey, okay? So if you recall, the one-way ANOVA, what it does is it tells you if there's a difference somewhere between these three groups, and that's great, but it won't tell you which groups are different. So it won't tell you if isolation, for instance, is different than groups of 2, but not different than groups of 4. Tukey will actually do that. It's going to compare each group to another group in a 2x2 set. So you'll be able to determine exactly where the differences are. So we're going to click Continue after clicking Tukey. Then you go into Options, and what I want you to do is I want you to click on Descriptives. This is what's going to give us our mean report. And I want you to click on Means Plot, because this is going to give us kind of a cool graph where we can actually look at the results. And click Continue. Okay, so then you click on OK, and just like that, a window is going to pop up, and it's going to generate results for you. Okay, so this is our descriptive statistics. What we actually want to do is copy this as an image, and then we'll paste it below. Okay, and every now and then the copy-paste function in SPSS glitches out. If it glitches out on you, don't worry about it. Just copy in what you have. So we're also going to copy in our ANOVA report. So this is specifically about the result of our ANOVA. Okay, and so that came down here. I'm going to shrink it just so I can get it to come up here. Okay, and what we can do here is we can see the means between different groups. So we can see that descriptively, people made more utilitarian decisions in groups of isolation. They made about 9 utilitarian decisions when they were by themselves, but they only made about 5 utilitarian decisions when they were in groups of 4. Okay, so we actually don't know if this is a significant difference, right? It seems like it's an important difference, but is it significant? And so when you go down here to your ANOVA, you get your F statistic, you get your degrees of freedom, but you also get your sig value, which we also refer to as your p-value, and this is 0.099. So what this basically means is that if everything was random and there's no real effect in nature or in the real world, that would mean that these groups are actually really different. There is a 9.9% chance that these results would happen randomly due to no actual true effect, okay? And so what we want to remember is in statistics and in science generally, we want to only accept things as a significant difference if they're below 0.05, which is a 5% chance of these things happening randomly. So anyways, That is a long-winded way of saying this value needs to be below 0.05 for us to say it's significant. It is not below 0.05, and therefore it is not significant. There's no significant difference between our groups in the one-way ANOVA. Now, what this hasn't done is it hasn't looked to see if there's a difference between isolation and groups of 4. And maybe there is, right? So we're going to go down to our post hoc, which is our multiple comparisons here, and you can actually see what it's doing. It's comparing here isolation to groups of 2 and isolation to groups of 4, and it's going to do it for every level of your test. And what we can see is isolation compared to groups of 4 is the closest to being different, but it's not statistically different. And so we also don't have a difference here on our post hoc. So we're going to copy this as an image, and we're going to paste it in down here. Okay? And then we have our graph, and this is really cool. This is our means plot that we asked SPSS to make for us. Graphs can be hard to make in things like Excel. If you do them right in SPSS, they'll come out pretty cleanly. And because we labeled our dependent variables, we get isolation groups of 2 and groups of 4 to actually come out as words on our x-axis here, right? Which is really nice, because if we didn't label it, if we didn't tell the system that isolation and groups of 2 and groups of 4 were the labels for 1, 2, and 4 respectively, then we would just get the numbers here, and it would be harder to actually interpret. If someone else was looking at the graph, they go, I don't know what I'm seeing. So this is all you need from SPSS for question 1. The other thing you're going to have to do, and I've already given you hints, is you need to make a conclusion about whether you can reject the null hypothesis. Okay? So I need you to write that down in the assignment below your output right here. Okay? So definitely do that. That's going to be required for full points. Okay, so in part 3, I'm going to talk to you about how to answer question 2.